now I will invite our next speaker, which is Maider Llaguno Munitxa. She's an architect and associate professor at the Faculty of Architecture at UCLouvain. Before that, she obtained 2 master's degrees in architecture in Barcelona and the University of Columbia. Then she did her PhD in Zurich, where she studied the architecture and urban design strategies to shape urban microclimates and air quality. And currently, her research work focuses on the study of data science and digital design tools for the development of novel design practices that aim to improve urban environmental quality and health. Yeah, you can come.
Let's start, sorry. Okay, so thank you very much for the introduction. I'm super happy to be here. So Alessandro, many thanks for the invitation, and to Brussels Institute of Advanced Studies overall, of course, as well. So the title of my talk is Data Practices to Assess Urban Environmental Exposures. And I'm going to give you a very short background of where I am right now, while you did a little bit. We had this problem earlier. Yeah. Let's see, I think it's coming back. I think it's the second one I used. Wait. I changed it to the second board.
Is it coming back?
Yeah, I'll do like, yeah, it's there. Let me share again. Okay, hopefully it stays. Sorry for that. So I am associate professor, as you mentioned, at the Faculty of Architecture, Architectural Engineering, and Urban Planning at UCLouvain. I'm also part of the Institute of Landscape, Architecture, and Built Environment Lab, and also member of the Architecture Clima group, where we very much focus on a grounding on human-centered vision to work always at the building environment scale to answer to questions of today and tomorrow related to environmental challenges. So within Architecture Clima, we have 4 teams, and I lead the team Urban Science, Climate, and Health, where I have the great pleasure to work with fantastic PhD students. I don't know whether this, maybe I have to swap. See. And postdoctoral researchers. If it happens again, maybe we change laptop. I don't know. Let's see. So here I see already some of them, so thank you very much for coming. I wanted to highlight 3 aspects that I find important when we talk about smart cities, and following up on Alessandro's introduction of the term, that are recurrent in our heads, right? As I talk here as an architect or urban planner, right? When we talk about the smart cities, an aspect that is important is that whether this has to be following top-down organizational systems or not, it's often kind of an echo we hear when we talk about smart cities. However, it's important that when we think about cities, we think about the city that is giving something, providing something for everyone, right? And in a way, this means that the city itself has to be created by everyone. The second important aspect is that oftentimes the smart city solutions are understood as oversimplistic solutions, no? That they forget the complexity of the city. No? So keeping in mind that cities are complex entities, it's another dimension I think we should all keep in mind. And thirdly, of course, we use lots of data with cities, right? We know that. That's oftentimes what we mean by a smart city, right? But this doesn't mean that we have the right data or we have the data we need to answer the question that we are asking. So today, I would like to reflect on the data practices that we can use, or some of them that we could think about to aim towards smarter cities or towards smart cities. So I believe that these data practices should consider multidimensional data to address citizens' needs and potentially through their direct engagement in these practices. So today we have access to very interesting data, right? This is data coming from an institution. You are all probably familiar with it, the GHESL data sets. And within it, we have the population dynamic data. We know when what is the number of people, how many people are in the city at night and during the day, right? But we have also other types of data that are really interesting, that are coming from hybrid research methodologies involving also citizens. The UCLouvain project that I'm sure most of you know about, that engaged nearly 20,000 people to collect NO2 concentration data using passive samplers for a month. And we had this, we were able to understand the spatial gradients to really find spatial resolutions for this particular time frame, no, in Flanders. So I'm here inviting you all to think a little bit about what it means to do citizen science projects, right? This is kind of a controversial term, maybe sometimes, but I invite you to think about it in a broader sense of the term, no? So if we go back to its definition, it's the science which assists the needs and concerns of citizens, right? So we all sort of agree with that smart cities should be doing this, no? And so also I invite you to think about how we could engage in these practices, right? I am showing here this kind of a gradient of taxonomy of involvement. So doing citizen science doesn't necessarily mean that citizens are measuring or are doing research. It could be a research question that is pertinent to a particular community that is developed, or it could be a co-created project. So there are many gradients that can answer this kind of philosophy, let's say. And so today I'll be talking about urban environmental exposures, or data practices as they relate to the assessment of urban environmental exposures. And these also kind of are very particular to the characteristics of citizens, right? To where they live, how they move, their background. We can be exposed to very different light pollution, very different air pollution, heat exposure, sometimes positive, sometimes negative. So what kind of data practices can we use to answer, to look into these assessments, right? And so I propose to focus on this kind of citizen-centered data practices that involve maybe collecting data, that involve maybe leveraging this data or compiling it. So the first project I'll be showing you, I'm going to be going briefly through a bunch of projects. It's on collecting data. So here we devised a must-have sensing kit. That was a little bit the joke we used to use. I was a postdoctoral researcher, so it was a few years back, supervised by Professor Bousset, and also we had very, very nice collaborators. So it was about putting together a sensing kit to collect data on micrometeorology and air pollution, affordably and accessibly. So this was the kit we developed. It was an autonomous kit so that it could be deployed easily. Maybe I have to stop and reshare again. Sorry for that. Yeah. Because it has magnets, so that it was supposed to be mobile, mobile urban sensing kit. And it had a solar panel on top, so it was autonomous with a rechargeable lithium battery. And then affordable sensors, some of them, but overall it was about $1,000 US to build this box back then, a few years back, as I said. This was the first iteration that we installed over the Seoul city bus network. 5 of them. They were running for a month, collecting data and reporting the data in real time, and involving students of the Princeton University that we went there, organized the installation, and then communicating the data to the student community over there to reflect upon the concentrations along the bus routes in real time. We continued working on the box. We did 3 iterations of it. Of course, we went through calibration processes. And within campus in Princeton, for a long period of time, we were mapping the concentration gradients. In this particular case, locating the boxes over the logistic vans of the campus that deliver the mail, basically. And to understand all the variations in the gradients that were happening in the campus. And if you know Princeton, this is not a big city, but still this was very much the case because it's next to Route 1, which is a very important artery with lots of traffic in the US. So the second dimension of the project, I keep on resharing, sorry, was the data communication. So we also put together an application to display the data in real time and also to be able to look at historical data. And I'm going to show the video directly. That worked in 2 ways. In a map view, so you could look at the Princeton campus map, and for every intersection of the Princeton campus map, you could get concentration values for temperature, relative humidity, and AQI. So this is every intersection. And we also had an augmented reality view of the same data exactly, so that we were accessing, you'll see it in a minute now. Yeah, that's soldering. I got a little accident. Huh? Yeah. So this was the augmented reality with the markers of the information about, in this case, AQI. And then you'll see in a minute also temperature and relative humidity. So it's kind of detecting the intersections that are within your field of view and adding this augmented reality layer. So you can, in theory, inform as a student, get to know which path you should choose, informed by the environmental conditions in your neighboring environment. This is the work of a PhD student that is currently working on this project and many other interesting things, Elena Gudo-Sierra, who has done a little project focused on collecting light pollution data in the Brussels capital region, in collaboration also with Alejandro Burgueño for this particular project. So this is Elena in the middle. She covered herself with a text, I don't know why, but that's her in the middle. So what we are seeing here is what's the scenario a little bit in Brussels in terms of the availability of this is annoying, huh? Sorry about that. Maybe. I don't know whether it's a problem. Yeah. Yeah. Okay, I reshare. All right. So the first thing we did is to look into what was the data availability in terms of light information for the Brussels capital region, because Elena is interested in evaluating or analyzing the safety perception or understanding the safety perception of pedestrians in the region. So for that, she really needs pedestrian level data to find spatial resolutions. So looking at the satellite images, this was 2 cores for her particular focus, and looking at the data we could get from Brussels, finally we learned that we only would know the geolocalization of the lamps, for example, but nothing much about the light environment, right? So Elena started looking into alternatives to collect data and also to develop a new application called AI Looks Tool, which is an application that would use Google Street View images, 360 images, with machine learning to compute the luxes using night view images. As you know, Google Street View night images are increasingly more available. So while now it's a little bit limited, we are expecting that very, very soon this will change very much so. No? And so she did two things: collect data and also work on this tool in parallel. So I'm showing you her case study. So she focused in two municipalities in the Brussels capital region, Molenbeek and Saint-Gilles, and within them about 5 squares in each. She took the night view images so that you can identify the squares. And from these squares, she collected data. With this criteria for the days, with this criteria for the hours. I'm not going to get into details now. And following a gridded fashion of data collection systematically. And the data types she was collecting was 360 images using our camera. These are not Google Street View night images. Then with a luxmeter and the coordinates as well. And then through machine learning, she computed the luxes using the picture she took to train the machine learning model, and through some augmentation processes, she computed the luxes. There you have an example of a case study. And we noticed that overall it was quite good, the results we were getting, with some exceptions. I'm showing you maybe one of the worst cases that we saw, the Place Maurichard in Saint-Gilles. I don't know whether you know it. So these are the measurements she took. So we are looking at the real luxmeter results, in the interpolated results, in the map. So if we compare this against what the AI Looks tool was giving us, we see a substantial difference, especially in the areas that were not very lit. And this is because in the training, like the images we use for the training of the AI tool didn't have as many also low lit images. So basically what we are thinking is that as the number of images grow, like with the Google Street View and so on, we were using, I forgot to say that, sorry, 500 something images. So that was the volume we used for the training. This will substantially change. So overall, anyhow, we saw very interesting results and kind of good agreements. And we think this could be a potential pathway to better understand illuminance in cities. Third project, I'm changing to the leveraging high spatial resolution air pollution data in New York City to understand neighborhood scale exposures. So this is the work of the postdoctoral researchers Firar Gerges, and through many professors and so on supervising. I'm not going to get into those details, mainly Professor Boussaid, again, with whom I worked for my postdoc. So this is also growing on the work I did through my postdoc. So probably you are familiar with the NYCCAS data for air quality or air pollution. About 100 stations collecting data for 10 years. That's the database we use, discontinued after. We stopped at 2018. I'm not sure whether they publish more data already. Bi-weekly data for many pollutants, as you can see here. This is how the device looks. And aside from the actual air pollution data, we also compiled many other indicators, meteorological and urban indicators. I'm not listing all of them. There were very many of them. And if anyone is interested, I'm happy to discuss about it. And for every one of the locations of the NYCCAS stations, we developed a footprint analysis, computing all the indicators at the different footprints, from 25 to 5 kilometers. I'm trying to check, yeah. And so using all this data, the air pollution information, the meteorological indicators data, and urban characteristic data, again, for all the footprints, then we apply the gradient boosting regression model to predict, using, again, the data we had, like taking part of it for the prediction, for the training, and then for the prediction, as is usually done, looking into the error analysis, and also to look into the attribution, to know which are the indicators that matter the most. And mainly we had the kind of also the question about, do the urban ones or the meteorological ones have a more important role? And so these are some of the results we got. On the left-hand side, you see the prediction errors. The mean absolute error, it's scaled from 0 to 1 for all the pollutants, right? They're organized in a grid fashion. So overall, the agreement or the error was quite low, but there are some places where we saw some sort of very hyper-local conditions were happening, right, that the model was not capturing. And looking at them in detail, one after another, we noticed that some of them were, for example, the exit of the Lincoln Tunnel, and so on. So positions where there is a very, like a high traffic density, so these kind of things are somehow need to be brought along to the model that we didn't do so, right? And on the right-hand side, we see also, especially on the top right plot, we see the results on the feature importance, right? So especially between the urban and the meteorological indicators. And what's interesting here is that the kind of the pollutants that are mainly sourced from traffic, for example, like elementary carbon or NO or NO2, the indicators that are most pertinent for those are urban, while those that are secondary pollutants or coming from other emissions, such as ozone or PM, for example, the meteorological indicators seem to be more important, right? And then kind of the thing becomes more complex looking at the indicators separately, but what's also interesting here is that to see that different indicators have different importance for different pollutants, right? When we try generally to bulk them up. While we saw that for the footprints, about 500 meters remained that was most important between all. So aside from this work, for using the same data, we also did a little visualization. So this is Broadway. So if you know, going from Battery Park all the way up. So we predicted PM in Broadway using these indicators, and together with Biaina Bogosian for the virtual pavilion of the Venice Biennale a few years back, we did this little piece called Every Environment that shows you the PM concentration as a graph, the city in the back, so you can, that side of Broadway in the back. And in green, we see the green infrastructure variability, and you travel all the way along Broadway. It's a video that goes like very slow like this, and you see it in a point moving along in plan. Second, leveraging citizen science data in the Brussels capital region to better characterize air pollution gradients and exposures. This is the work of Neisha Eden, who is sitting right there. I'm only going to, she's a postdoctoral researcher. I'm only going to show you the very initial work because she joined just a few months back. So the second implementation that followed the Curiosoneusen, right, was the Curiosoneur, which I guess you all know about. In this case, installed in the Brussels capital region, also passive samplers for NO2, for a month. In this case, less people, but 2,483 citizens got engaged to do it. This is enormous. I mean, there are not many cities with this type of data. So Neisha started looking into this data, comparing that against a model that, the Irseling model that is commonly used in Belgium. And now what we are looking into is to apply this kind of similar methodology that we used for the New York case, but using the Curiosoneur data as a background. Also, the work of another PhD student, Zhengshuo Huang, leveraging on population dynamics data to understand environmental exposures in the region. So in this case, the citizen-related data he's using is the population data I mentioned you about earlier. So the population dynamics data, day and night population, that's the difference. in the population. So how can we rethink exposure? Because when we do exposure, usually we think about census population, right? But there may be more or less people in a particular place in a city that are not necessarily reflected by the census numbers, right? And also when we think about exposure, generally we think about exposures separately. Heat exposure, air pollution exposure, and so on and so forth. So Yang Xu is also looking at these things in conjunction. So the first thing he did was to compare kind of more traditional exposure method where we use, once again, census population versus using, again, this is data for Brussels. I'm not trying to generalize for other cities, while it's very likely that it wouldn't be too far. We see that there is, in general, just qualitatively by looking at the plots, we realize how there is an underestimation of the exposure if we use a traditional method, both for heat and also for pollution, NO2 in particular. In his work, and I'm not trying to explain all the projects, of course, just giving you a hint of them, but he's also looking at very many indicators, again, like NESHE, urban indicators, meteorological indicators, socioeconomic indicators. We have lots of data in Brussels, so, and trying to have a look at also urban green infrastructure, at different segments of the soft mobility routes in Brussels. So he took all the region of Brussels, separated it into the segments, as you can see it here. And he computed all these indicators for every one of these segments, including the ones I mentioned earlier for the exposure. And what the last kind of investigation he did in relationship to this was evaluating or defining the clusters that would be grouping the different exposures in those different segments across the region, so that we can think about those soft mobility routes, for example, like for cycling, right, that would have a bigger need or more pressing need for improvement, no? If we need to green them, or we need to add some sort of canopy cover, we need to think about other alternative routes, right, for soft mobility users. And lastly, a project focused on compiling data to inform and update an urban environmental assessment dashboard. This work was done by postdoc Constantina and Stasiau with many collaborators in the lab, including Elena, who I mentioned earlier. Constantina finished already, so he's no longer with us in Belgium. In this particular case, the ambition was to create a prototype of a part of a city, because we just didn't have the resources to focus in the whole, or the whole region, I mean, to do interactive environmental assessments. So how can we look at a part of a city and analyze different possibilities for environmental assessments interactively? So we focused on this. I don't know whether you are familiar with this area of the city. We are nearby Gare du Midi. It's called the Pas de Heibart, or sorry about my pronunciation. And for this portion of the city, we computed and we compiled lots of data from the soil to the street level, to the building, to the vegetation. And I explained, for example, how it went for the vegetation, and this kind of applied for all the columns that you're seeing here. So trees, some of them were documented by one municipality, other trees by other municipalities, some were documented by the region. There were many trees that were undocumented. All the private green was undocumented, so it was a very tedious process of bringing together all these different data sets to then put together this 3D portion of the city that covered the underground and the overground. And I'm going to jump directly to the video. Hopefully this is working much better. Thank you. So this was a web application we did that had two windows. This was the first one that operated at the element level. So you could click on elements in this portion of the city and learn about the attributes of that particular building, the kappa key, all the information related to that building, the tree, the sidewalk, everything. And the second window was operating at the parcel level, so you had to click on the parcel. And this was, by the way, funded by Innoviris. You had to click on the parcels button. And there you could access parcel level information. And why was that important, we thought? Because usually if you are a citizen, you own a property or you live in a block, no? You want to know how that parcel relates with the context, no? With the general block, with the district, and so on. Do I have more greenery than the rest? Can I still build more, right? So what we did here is create a dashboard where you can, of course, again, click on the parcel and look at the attributes in a tabular form, as it was the case for the isolated elements. You can also look at it a little bit in a more qualitative, explanatory way on the left-hand side. And finally, you could look at it, maybe I can go through a little bit. You have the soil information, then you have the building information, always following those columns I was mentioning earlier, right? The roof characteristics, vegetation, and so on. And then in the bottom, we had the dashboard, where you have the soil cover of the parcel on the left-hand side, the soil cover of the block, followed by that, then the soil classification index, so that you have the density potential also. And here, if you see DPPA versus DPBL, it's comparing your parcel against the block. So you know how you are sitting in terms of your statistics in relationship to the neighboring parcels. And then same for the greenery, so that's pretty low here. And also the heights of the building, of the facade, and the vegetation in your parcel. And the ambition of this really was, but I mean, the funding was what it was, the time frame that it was. But to make this, in a way, thinking about the future, the maintenance of the project, right? To allow for a participatory GIS, so that citizens, for example, could also add trees, could also reposition things, could reconstruct the database, right? So we started working on this together with Constantina, reflecting on these ideas. And of course, to communicate this, to make this accessible to citizens who really don't know about their parcel. From here, you could also download the data and all of this, of course. And to know about your parcel in relationship to the other parcels nearby you, right? Do I need to green more? Am I being a good neighborhood because my parcel is kind of a good parcel in here? So I think I'm going to stop like this suddenly. I don't have a conclusions page, but thank you very much.
Thank you very much for your talk.
I gave you this. This one is yours, no?
Has anyone a question for Maider? Yeah.
Thank you for the presentation. I don't know if you're taking questions. Thank you for the presentation. Just want to ask you if all this data, maybe the one regarding Brussels, is there like a common repository? Is the plan to do that, or
you mean the last one? Or?
No, I mean in general, like all the sensor data, this kind of like the light information. If you know if there is a common place where we can find all this data, or if there is a plan in the future to do that, I don't know.
About the plan, I'm not sure, but as far as we know, there's no common place where we can find the data. And this is so the case for very many cities, not only Brussels.
Yeah, I know.
I think actually we are in a luxurious place in terms of data accessibility here. But for light information, it was very scarce what we were able to find. And we made some requests, and So it was something that where we, spend some time on. For other things, for greenery, there is quite a bit of data, but it's very sparse. So it's managed by municipalities, it's managed by the region, it's managed by, you have LiDAR data also that you can use. But in a way, it takes, you have to bring together that data. So there's nothing like a coherent database for light, a coherent database for greenery,
Okay.
So it does require a process. So.
Okay.
But if you need something in particular, or we are happy to, you can get in touch. And we can
Yeah,
think
of
about
course.
it.
I was just wondering, because it seems like there is a lot of data, but it's really hard. I mean, it would make sense for me to put everything in the same place, but
Yeah. But it's a data-rich place where we are at. So. Yeah.
Thank you for your talk. So to connect to his question, since you were saying that this data is quite sparse, is there any study, do you have an idea like how reliable these data are, in the sense, are there any study on the uncertainty of this data or something like that?
On what, to what data set are you referring to?
In general, like any of the ones you are using.
I think it very much depends on what data you are referring to. If we continue with the greenery, it is reliable, but it's not complete, right? Because also trees evolve, right? So we should be documenting them with a certain periodicity, right? So some other cities have been, and also I think it's the case with a project in Brussels, also involving citizens to better document the tree canopy. Also with the initiatives to document the undocumented, right? Not only the public green, but also the green that it's in courtyards or in private properties, which are contributing to the well-being of citizens in general, even if we cannot access it physically, right? So I cannot answer that question because it very much depends on the data you are referring to. In general, I think the data the region provides, it's reliable. But yeah, it needs to be updated.
Any other question?
Maybe because this discussion is interesting. Do you have I understand that the levels of fidelity of the data changes, of course. This is true for every set of data. But is there a reflection on how to introduce the level of fidelity on the outcome that this data would actually produce? You see what I mean? So is there like in which way the level of fidelity of the starting data will have an impact of the confidence of taking a decision, like leveraging the data?
Mm-hmm.
The point
You should have it. Yeah, it's, I continue with the green just to be a little bit coherent. But for the case of New York City, there was an initial study done many years back, and I'm going to give names and so on because I don't remember exactly all the names. The contribution of the green canopy to the heat island and so on, right? But they were only using public trees. So they said finally it doesn't, it helps, but not as much. But the more recent study where they looked at all the tree canopy, updated tree canopy, including the undocumented tree canopy, then it does have a big role. So yeah, I mean, this changes the whole,
Thanks. Thank you.
Okay, thank you very much.
Yeah.